Hey, hi guys. In this video, let's try to understand a very important topic in data world. And this is something which is common across a lot of databases and data warehouses, but not only limited to Databricks or Spark, Apache Spark. So we'll see what is predicate pushdown, and we'll talk about what is projection pushdown and what is partition pruning and what is this dynamic partition pruning. So before we go into the more details, let's try to understand this on a high level, and then we'll go to the Databricks, and there we'll write some piece of code, and we'll try to understand what is happening internally when you fire Spark queries. Cool. So if you see this predicate bootstrap, which is something which actually helps in filtering required records. Say you have a table, and the table might be having billions of records, and you're doing a couple of transformations on top of that table, and finally you're putting a filter where ID less than 50. Now, what Spark does, it identifies that you're only interested in the records where ID less than 50. So with that, it actually pushes those filters to the source side, and it will make sure it is only reading those required 50 records where ID less than 50, and then it will bring those into memory, and on top of that, your transformations will be executed, and then finally you will get the result. Now, the whole idea here is to make sure you're only reading the required records so that you will not put more burden or you will not read unnecessary records into the memory. Cool. So that is what I have written here. So which actually helps in filtering required records. Now coming to the projection pushdown, which is something which helps in filtering required columns. Say you have a file, and that file might be having a lot of columns, maybe 1,000 columns and 2,000 columns. And most of the times, you may not be interested in scanning or reading all the columns. Say you have a requirement to create a table, and maybe aggregate a table with just 10 columns, or you have a requirement to just read four columns out of those 10,000 columns. Now, what Spark does, it identifies that you're only interested in reading those, four columns out of 1,000. Now, when it is reading, it will bring only those four columns into the memory, and on top of that, what transformations will be executed on whatever code you have written. Now, the whole idea here is to make sure it is only scanning the required columns, so that you will not again put more burden, and you will not bring unnecessary data into the memory, right? So that is what I've written here. This is actually something which helps in filtering required columns. Now coming to the partition pruning, and so this is at partition level. Say you have a table, and that is partitioned by country, and that table might be having a lot of columns, maybe billions of columns, and each partition is having millions of columns. Now, when you put a query, the query would be something like select start from table where country equal to India. So what it does, it will directly go to the country India partition, and it will scan that India records, and it will skip those partitions where country not equals to India. Now, again, here the whole idea is to make sure it is only scanning the required partitions, and skipping irrelevant or not required partitions. And this is at partition level. Now, coming to this dynamic partition pruning, so this is a very interesting topic. And this is something which is only available in Apache Spark, and you will not find it in other technologies. Again, in Spark, I think this is only applicable in Spark 3 or Dex. Before that, this feature is not available. And this is a combination of predicate pushdown and partition pruning and broadcast join, which actually leverages all these three concepts to optimize our queries. Let's go to the Databricks now, and we'll see more details by writing some code here. So now I'm in my Databricks, and if you see this, where is this? Predicate push down. Yeah. So I have a data frame which is created out of reading this packet file, and if you see this packet file which is generated out of some test data, which is having close to 1 million columns. I have generated this using Spark data range. And this is having five columns, which is ID and call one, call B, call C, and call D. And on top of that, we have added this lit function to add these four columns. And then finally, I have written this to a Parquet file just to generate some test data, right? Now, if you see this query, I'm reading this Parquet file, and on top of that, I'm doing a couple of transformations. And then finally, I am putting a filter where ID less than 30. Now, what Spark does, ideally, if you see this code, the order, it is reading all the data and then it is applying these transformations and then it is applying this filter. But Spark is very, very intelligent here. It will not scan all the data. Instead, it will push this filter to the source side. Means while reading itself, it will bring this columns where ID less than 30 into the memory. And on top of this, two transformations will be applied and finally you will get this data, right? So now let's confirm also. Let us also confirm this in a couple of ways. We'll try to print the physical plan for this query, and then we'll also go to the Spark UI and see how much data it is really reading. So I'll just comment this here and print a physical plan. Okay, I think I need to execute this again. Let me just execute this in a specific cell. Okay, so we got the physical plan here. If you see, it is reading this file, which is located in this TBFS. And while filtering this, while reading this, it has applied a couple of filters. If you see this data filters, where it is applying ID is not null because I am only interested in the records where ID less than 30. Means definitely there shouldn't be any nulls. So with that, it has applied a filter where ID is not null. As well as if you see here, it also applied another filter which where ID less than 30. So ideally, if you see here, I applied this filter after doing this couple of transformations. But what Spark is doing, it is pushing this filters to the source side, and by reading itself, it is only reading this 30 records, right? So that is what you can see from this physical plan. We'll also go to this Spark UI and see how many records it is reading. So for that, I'll just comment this. Let me do a display here. So now if I go to the Spark UI, I'll just go to the SQL data frame tab. So this is my query. Okay. So now if you see here, here you will need to concentrate on a couple of things. First thing, what it does, it scans these columns, which is triple line, triple line. This is what we have it in source. But while bringing that into memory, it only brought this 29 rows. This is, ID less than 30. And on top of this, your transformations will be executed. And then finally, you'll get the result. So as I said, the whole idea here is to only bring the required required rows into the memory. So with that, it only brought this 29 rows into the memory, right? So that is what I wanted to talk about this predicate pushdown. So wherever you apply the filter, maybe you apply it in between the query or after the query or at the end of the query, it will make sure it is applying those filters and it will pushes that into source and it will only filter those required records. That's the whole concept of predicate pushdown. Now, let's also see this projection pushdown. Where is this? Yeah. Now coming to this projection push down, so this is at column level. What this does, you might be having a lot of columns, maybe thousands and 2000s of columns, but it will identify what all are the columns which actually needed to build this output, and it only bring those columns into the memory. For example, in this example, if you see, if I filter the schema, it is having a lot of columns. Df dot print schema. It is total having five columns, and but if I print this physical plan here, it will only scan this required columns, which is ID and call one. I'll just print plan here. Yeah. So if you see here, while scanning this, it only brought these two columns into the memory because this is what I need to build this final output, right? So with that, it identifies that no, these are the two required columns, and it doesn't need to scan other columns. And it only brought this to memory, right? So the whole idea is to here again only bring those required columns into the memory and calculate the result on whatever code you have written. So yeah, that is what I want to talk about this projection push down. Now coming to this partition pruning, as I explained earlier, this is at partition level, and here the whole idea is to make sure it is only scanning the required partition and skipping not required partitions. So here I have a data frame, and this data frame is something which is created out of this file two. Now, if you see this file to how it is generated using again test data. So I have three different data frames where I have created one partition for India, one for Australia, and one for Pakistan. And finally, I did a union, and I have written this into file two. So if you do this percentage fs ls this path, yeah. So it only has three partitions, and now if I put a filter on where country equal to Australia, what it does, it will directly go to the Australia partition and it will skip India and Pakistan partition. So yeah, again, the whole idea is to only scan the required partitions. So what I'll do, I'll just put a explain here and see what is happening. Yeah. So if you see here, there are no data filters because it is not using predicate pushdown feature. Instead, it is using partition pruning. And here, if you see in required partition filters, it applied this country equal to Australia, and which will directly go to that Australia partition, and which will read this data. Yep. So that is all I wanted to cover on this partition pruning. Now let's talk about this dynamic partition pruning. So this is something which is only applicable. Just a second. I think there is some issue with my screen share. Hey, there is some issue with my laptop. For that, I had to stop the recording and I had to resume that. Okay. Anyways, let's talk about this dynamic partition pruning. And this is a combination of predicate pushdown and partition pruning and broadcast join. So now, so to utilize this feature, ideally, you should have a star schema model. If you see in star schema, you will have a big fact table, and fact table will be surrounded with few dimensions, and you'll join a fact and dimension based on certain field, and finally you will derive some insight, right? Now I'll show you some query and I'll tell you how this Spark will convert this query into a different query so that it can effectively join this fact and dimension. Now the first prerequisite is this fact table should be partitioned, right? So whatever column you are actually putting a filter, and so this fact table should be partitioned on the uh, same column. So what I'll do, I'll just do a describe formatted, and we'll see whether it is a partition table or not. describe formatted fact. Yeah. So this is a partition table, and this is a partition and order date. So this is the prerequisite. If your fact is not partitioned, then it won't be able to apply this feature, which is a dynamic partition tuning. Now, what it does, if you file query something like this, where you're joining fact on dimension based on this order date, and you're putting a filter on, order date. Now, what it does, first of all, it will apply the predicate push down to dimension. That means from the dimension, it will filter all the records where order date equal to 23, 15, 08, right? So with that, your dimension table will become even smaller. Ideally, if you see dimensions which will be smaller in size, but now since you're applying this filter, this will even the size will even become come lower. Now, what this does, this will also push this filter into fact. So ideally, if you see this query, I'm only asking Spark to put this filter on dimension, but this will also put this filter on fact, and from the fact also, it will filter the records where order date equal to 23 15 08, right? Now after that, what it does, now you have your big fact table, and that even got reduced because you applied a filter on this order date, and you have a smaller dimension. So ideally, dimension will be smaller in size, and on top of that, you applied this filter, right? And what this does, this will basically broadcast this will broadcast this dimension table into all our executors, and on top of that, your fact and dimension will be joined. So I'm not going to explain this what is broadcast join, but you can think of like this is a very effective join where sorting will not happen, and shuttling will not happen, and everything will be done within the same worker node, same executor, right? Now, three things here. What it does, it will apply predicate push down on dimension, and it will make sure it is only reading the records where date equals to 23 59, and it will also put the same filter on fact, and even in fact, it will only read these records, right? So that's second thing, and third thing is it will broadcast this dimension to all the executors, and your fact and dimension will be joined using broadcast has join. Cool. Now let's do one thing. Let's try to filter the records as well as see the physical plan, and we'll see what is happening here. First, let's try to see the physical plan. For that, I'll just put df.explain here. Now we got a lot of info. Let's try to understand one by one. So if you see here, this is the fact reading. Right? So this is what I said. If you see here, fact is only reading the records where order date equal to 2023 15 and 08. And if you also see here, there is a partition filter where it used this partition pruning, and it only pruned this partition, and it only read this order date equal to 2023 15 08. So similarly, if you see for dimension, it applied this predicate push down, and it only read the records where order date equal to 2023 15 08, right? So with that, we have covered two things. Third thing, what I said, this dimension will be broadcasted to all the executor, right? That is what you can see here. So for the dimension, what it is doing, it is applying this broadcast as join, and the fact and dimension will be joined using this broadcast join, right? So yeah, that is what happening here. Here you haven't provided any hint, or you haven't even filtered this fact. But the moment you apply this filter and dimension, it is pushing this filter even to the fact, and it is also using broadcast join to join this fact and dimension. So yeah, that is what I wanted to cover. I think I covered everything. So where we discussed about predicate push down, projection push down, partition pruning, and dynamic partition pruning. So I hope you got some info on what is this about. Just comment it down if you have any questions, and I'll be happy to answer that. Thank you so much, guys.